Hello, Math Study students. In this lesson, we're going to take a look at the sine and cosine rules that are very helpful to use to find unknown sides and angles of triangles that are not, I want you to write that in capital letters, that are not right angled. Okay, in other words, the sine, cosine, and tangent ratios and inverse functions that we have been using are only to be used for right triangles. The law of sine and the law of sines and the law of cosines is what we use for triangles that are not right angled. Okay, so let's start with the sine rule. You'll use the sine rule when given the following information about a triangle, either two angles and a side, or two sides or a non-included angle. Don't worry so much about memorizing this. It will become obvious to you when to use the law of sines. So let's go ahead and state the law of sines. It says given any triangle ABC with angles A, B, and C and opposite sides A, B, C respectively. In other words, the angle that's opposite angle A, let's see, the angle that's, the side that is opposite angle A we'll call little a, the side that's opposite angle B we'll call little b, and the side that is opposite angle C we'll call little c. Whenever we have a triangle set up like that, then the following relationships will always be true. That the sine of angle A over A is equal to the sine of angle B over B, and that's equal to the sine of angle C over C. So you can see how we can use this law to set up proportions to solve missing parts of a triangle. Another way we can state these same three laws is we can just flip them over every ratio, and so we would have A over the sine of A is equal to little b over the sine of angle B, which is equal to little c over the sine of little c. So let's take a look at an example where we use the law of sines to find some missing parts. So in this example, it says in triangle ABC, B is 16 centimeters, C is 10 centimeters, and angle B measures 135 degrees. So part A says represent the given information in a labeled diagram. So let's go ahead and draw a triangle, and let's call the triangle ABC. It's important that you don't draw a right triangle, because this would not apply to a right triangle. Let's see, we're told that little b, which would be the side opposite angle B, is 16 centimeters. So we'll label that 16 centimeters. We're told that C, little c, that would be the side opposite angle C, is 10 centimeters. And we're also given that angle B measures 135 degrees. Okay, so we have part A done. We've represented the given information in a labeled diagram. Now let's find the size of angle C. So we're trying to find the size of this unknown angle C. So what we'll do is we'll use the law of sines, where to find angle C, we'll use little c that's opposite angle C, and then we'll also use angle B and the side that's opposite angle B. So for part B, we'll set it up like this. We'll say that the sine of angle C over the measure of little c, which is 10, is equal to the sine of angle B, that's 135 degrees, over little b, which is 16. Okay? So now at this point, you could just type this into your calculator if you have an Inspire calculator and use NSolve, but you don't always have NSolve available. So let's talk about how we would solve this. To solve it, we would cross multiply, and then so we'd have 16 times the sine of C equals 10 times the sine of 135. Then to solve for the sine of C, we'd have to divide both sides by 16. So let me write that down so you can see what I'm talking about. We would have 16 times the sine of angle C is equal to 10 times the sine of 135 degrees. Now, if I'm trying to solve for C, let's first of all isolate the sine of C. So we'll divide both sides by 16. So we would have that the sine of angle C is equal to 10 times the sine of 135, all divided by 16. And then last but not least, to find C, we know what C's sine is, so let's use an inverse function to find out what C is. So we would say that the measure of angle C is equal to sine inverse of 10 times the sine of 135, all divided by 16. So you can type that into your calculator then and find out what C is, and C turns out to be 26.2 degrees. Now, without any directions about rounding, I'm just going to go ahead and default to 3 significant figures. Okay, so that's letter B. And then letter C says, hence, find the size of angle A. Well, if we know the size of angle B and the size of angle C, I'm going to go ahead and label C as 26.2 degrees. Then all we need to do is subtract 135 and 26.2 from 180. So for our answer for C, let me just go ahead and write it down. For C, that would be, let's see, 180 minus 26.2 minus 135. So that turns out to be 18.8 degrees. Okay, and we'll go ahead and label it in our diagram as well. Okay, then let's use the law of sines again to do this example. It says in triangle PQR, find the length of RQ. Give your answer correct to 2 significant figures. Let's underline that because that's not the usual case. We're going to just do 2 significant figures. Okay, so if we're trying to find RQ, that's this sine. That is opposite angle P. So if we're going to be using the law of sines, let's go ahead and find out what angle P is. Well, just take 180, subtract 20, and subtract 82, and that turns out to be 78 degrees. So let's go ahead and label P as 78 degrees. And so now I'm going to call RQ, I'm just going to call it X, or I guess maybe let's call it little p to be consistent with what we've been doing. So let's call that little p. So now we can use the law of sines, and we can say that the sine of angle P over little p is the same as, let's use angle Q, take its sine and put it over 10. All right, so our proportion would look like this. The sine of a 78 degree angle over little p is equal to the sine of, 82 degree angle over 10, okay? So cross multiply and solve. Let's see, we'd have P times the sine of 82 is equal to 10 times the sine of 78. Now I'm just writing this out, but remember you could also use NSolve on a calculator. So that means P is equal to 10 times the sine of 78, all divided by the sine of 82, which is equal to 9.9 kilometers. Okay, so let's go ahead now and talk about the cosine rule. Use the cosine rule when the following information is given about a triangle. When you have 2 sides and an included angle, or you know all 3 sides. And again, we have the same triangle set up with angles A, B, and C, and then little a, little b, little c are across from those angles respectively. So to find a side, I'm going to write this law of cosines all the different ways. So let's start with little a. And the law of cosine says that little a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. Notice what will match will be little, well, not match, but correspond. We have little a here and the cosine of A at the end. Now, another version of that same law is, what if we start with b squared? Well, then b squared would be equal to a squared plus c squared minus 2ac times the cosine of angle B. And then the third way we can write it is that little c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. Now, if you need to find a side, this is the version of the law that you'd want to use. But if you're asked to find an angle, I'm going to just rewrite the 3 laws, but all I'm going to do is I'm going to solve these for cosine of A, cosine of B, and cosine of C. So if I take this equation and solve it for the cosine of A, what we would have would be that the cosine of A is equal to b squared plus c squared minus a squared all over 2bc, okay? So that's what the cosine of A is equal to. So if I needed to find A, I could take cosine inverse of this ratio, okay? If we solve the second law for b, then it would look like this. Cosine of b is equal to a squared plus c squared minus b squared all over 2 times a times c. And then if we solve the third one for cosine of c, then we would have a squared plus b squared minus c squared all over 2 times a times b. So let's take a look at this first example where we will use the law of cosines. It says in triangle ABC, AC is 8.6, AB is 6.3 meters, and the measure of angle A is 50 degrees. So all that is given here. So now we're going to find the length of BC. Well, the length of BC is the length that's opposite angle A. So let's go ahead and call that little a. And then I've gone ahead and I have written out the law of cosines that helps us find A squared. And then notice if a squared is equal to all this, we can take the square root of both sides. To find a, it's just simply the square root of b squared plus c squared minus 2bc times the cosine of a. So let's go ahead and plug that information into our equation to find a. So a would be equal to the square root of little b squared. Well, little b squared is the side opposite angle b, so that's 8.6 squared. So 8.6 squared plus little c squared is 6.3 squared. That's the side opposite angle C, minus 2 times b times c, which is 6.3. Oh, whoops, 6.3. And then times the cosine of angle A, and angle A is a 50-degree angle. So this is arithmetic that you can do in one step on your calculator, and when you do, you should get that A is equal to 6.63. Notice we're going to write that to 3 significant figures because we didn't have any directions to tell us otherwise. Okay, so now let's look at the next example. It says X, Y, and Z are 3 towns. X is 20 kilometers due north of Z. Y is to the east of line XZ, and the distance from Y to X is 16 kilometers, and the distance from Z to Y is 18 kilometers. Well, we better do this part A, represent this information in a clear and labeled diagram. So just a reminder, let's just draw a little map here. Remember, north, south, west, east. Those are your directions. So if we are told that, let's see, X is 20 kilometers north of Z, then let's go ahead and draw a vertical line and put X at the top of that vertical line and Z at the bottom, okay? And then we're told that Y is to the east of XZ, so Y would be over here somewhere. And so let's just put a point Y and finish our triangle. Then we're told, and this may not be drawn to scale, but that's okay. We're told that the distance from Y to X is 16 kilometers. So I'm going to put 16 kilometers right here. And the distance from Z to Y is 8 kilometers. Okay, so I think we have everything labeled. Oh, whoops, I missed one thing, and that was, remember that X was 20 kilometers north of Z. Okay, so we can see that we know all 3 sides, so this is going to be a good time to use the law of cosines. We've got part A done, represent this information in a clear and labeled diagram. So now let's find the size of angle X. Okay, so if we're going to find this angle X, then we need to use the form of the law of cosines that's solved for the cosine of X. So let me just write that out. It would be cosine X equals y squared plus z squared minus x squared all over 2 times y times z. And we can even take that a step further and say, well, then x would be equal to cosine inverse of y squared plus z squared minus x squared all over 2 times y times z. Okay, so then let's go ahead and plug that information in to find our answer. We'll take cosine inverse of y squared is 20 squared, because that's the measure of the side opposite angle y, plus z squared would be 16 squared minus x squared is 8 squared, and that's all over 2 times, 2 times y times z, so that would be 2 times 20 times 6. Or excuse me, that's supposed to be 16. Z is 16. So we can see how we can type this in. You only need to touch your calculator one time, take cosine inverse of this ratio, and when we do, we get that angle X is approximately equal to three significant figures, 22.3 degrees. So now we're going to take a look at how we can use trigonometry to help us find the area of a triangle. So what you are already familiar with is how to find the area of the triangle when you know the measure of the base and the height of a triangle. When you know that information, you've used this formula for years. Area of the triangle equals 1/2 its base times its height. So let's see if we can use that formula to calculate the area of this triangle ABC. Well, remember, a base and a height need to be perpendicular to each other. So if we use 10 for the base of this triangle, we're going to have to sketch a height, draw an altitude, let's call that H, and then we don't know what H is, but we can use trigonometry to find out what H is. So if we take a look at this triangle, oops, I kind of wrote over my right angle, let me fix that. Okay, so if we take a look at this yellow right triangle, and we work off of this 42-degree angle, we could use this hypotenuse and this opposite side to find out what H is. So with respect to the 42-degree angle, H is the opposite side, and 7, of course, is a hypotenuse. So the sine function is the one that deals with opposite and hypotenuse. So we are going to say that the sine of a 42-degree angle is equal to opposite of our hypotenuse, so that would be H over 7. And then if we solve this equation for H, multiply both sides by the sine of 42, then we'd have H is equal to 7 times the sine of 42. So now we know what our base is. The base of our triangle is 10. The height is 7 times the sine of 42. So we can take those two values and plug it into this equation. So to find our area, we're going to take 1/2 the base, which is 10, times the height, which is 7 times the sine of 42. And then we can do all that work in the calculator, all that arithmetic, and we would end up with 23.4. Now this was an area problem. We were asked to find the area. We're measuring in centimeters, so that would be 23.4 centimeters squared. So now let's look at a new formula to find the area of a triangle, and this will use use trigonometry. So again, given a triangle ABC with angles A, B, and C, and opposite sides a, little b, and little c respectively, a triangle like this, we can find the area. Capital A stands for the area. I'm just going to write that so you don't think I mean the measure of angle A. The area of this triangle is going to be 1/2 times A times B times the sine of angle C. Or we could write it like this. It would be 1/2 B times C times the sine of angle A, or we could write it like 1/2 A times C times the sine of angle B. So let's use that formula then to do an example. It says calculate the area of a triangle ABC. So since we know what the measure of angle C is, and we know what little a is and what little b is, let's use this form of the equation. So to find the area of this triangle, we're just going to take 1/2 times a times b, so that would be 8.6 times b, which is 6.3, and then we're going to multiply that by the sine of a 50-degree angle. And then again, that's all arithmetic that can be done on the calculator, so your answer turns out to be approximately 20.8 meters squared. Okay, if you have any questions about these notes, let me know. Homework is in Google Classroom, so you can get started on that, and I will see you in class next time.